Hello, welcome dear students. Right now we are going to solve the next exam for you, IGCSE Physics, Paper 2, Multiple Choices, Extended Exam, October-November 2024, Paper 2, Variant 2. So, as you know, 40 MCQs, you will have maximum time of 45 minutes. So this question paper, again, as usual, may have maximum 8 challenging questions and almost 10 straightforward questions, and remaining 22 to 25 will be medium order of thinking questions. So let's start. Question 1. Two forces with the magnitude F1 and F2 act on an object at right angles to each other. What is the magnitude of a resultant force? So dear students, you know when two forces are acting at right angle, so the resultant force is the hypotenuse of a triangle. And hypotenuse of a triangle could be found using Pythagoras theorem. So if this is F1, this is F2, so you will do F1 square plus F2 square and square root. The right option will be F1 square plus F2 square root, option A. Pythagoras theorem you have to apply for the forces at right angle, so option is A. Proceed to question 2. A boy takes 30 minutes to cycle the distance of 8 kilometers. He then walks further 2 kilometers in this time, 15 minutes. What is average speed? Average speed will be, my dear students, total distance over total time. Total time, we know the first one is 30 minutes and the second one is 15 minutes. So the total time is 30 plus 15, 45 minutes. So when you write here 45 minutes, you will divide by 60 so that it becomes hour. Okay, now the distance. The total distance traveled is, first distance was 8 kilometers and the second distance is 2 kilometers. So 8 plus 2. So it is 10 divided by 0.75. 13.33, the right option is D. We proceed to question number 3, my dear students. It's about kinematics and motion. A small light ball is dropped from a top of tall building. It's a light ball and tall building, so it means there is significant air resistance. And whenever there will be significant air resistance, it means its acceleration will decrease. Graph will be no longer straight line. So A means acceleration is constant, wrong. B means constant acceleration, then constant deceleration. Wrong answer. C. C is the correct answer. Look, as gradient is decreasing, it means acceleration is also decreasing, eventually reaches terminal velocity. So right option is C, my dear students. Over here, they did not tell you that there is air resistance, but you have to figure out because it falls from a tall building in air. So whenever bodies, they fall from tall buildings or tall heights, the acceleration decreases due to significant air resistance. We proceed to question number 4. Question number 4 says, which statement about gravitational field strength is not correct? Wrong statement. Gravitational field strength, not correct. It changes the mass of an object. No, my dear. Mass never changes due to gravitational field. Okay? So, other things are okay. So, gravitational field strength is equivalent to acceleration of free fall. Yes. A is actually the G. Newton per kg, yes. Magnitude is different on other planets, yes. So option A is wrong. Move to question number 5, my dear students. 3 liquids P, Q, R have different densities and do not mix. The liquids are placed in a measuring cylinder and allowed to settle. A small block is then dropped in the measuring cylinder and comes to rest. So it means, first of all, decide the order of their densities. First you can decide, my dear students, and then you can go ahead. So my dear, this is the most dense and this is the least dense. Since the block goes through R, so density of the block is more than R. It goes through Q, also more than Q. It floats on P, so it is less than P. So which statement about the density of block is correct? Equal to Q? No, it is more than Q. Greater than P? No, it is less than P. Greater than the density of R? Yes. Less than Q? No, more than Q. So option is C. Proceed to question number 6. The diagram shows a uniform beam pivoted at its center. The student applies two forces, F1 and F2, as you can see. So which row is correct? Okay, so first row is talking about clockwise movement. Let's talk about clockwise movement. This causes clockwise movement. You can see that. So clockwise movement is F2 multiplied by D4. So F2 multiplied by D4 is the clockwise moment. So F2, D4, these two options. Now we need to choose for the anticlockwise moment. So let's read anticlockwise moment. So anticlockwise moment, I'm using a red color for you. It's this one. Anticlockwise moment. So this is F1 times D3. Option is D. Very easy question. We proceed to question number 7, my dear students. Which expression can be used to find impulse? I told you in the previous video for variant 1 that the impulse have two equations. Either it is change in momentum or impulse is force multiplied by time. So force multiplied by time, the option A is available. It's correct. Proceed to question number 8. Which row shows the process by which energy in sun is released? We know energy in sun is released by nuclear fusion. Nuclear fusion. And now they say, and by which it is transferred to earth. From sun to earth, only radiation. Only radiation. And now they say the way in which it is stored once reaches earth. So reaches earth, on the surface of earth it reaches, it is stored, so it is as biofuel. Why biofuel? The living things they absorb, like trees, yes, living things, all. So they absorb the energy, and energy in the living things is called biofuel. Mainly these are the trees, so option is D, my dear students. After that, we proceed to question number 9. An object has a mass 20 kilograms taken to the height 4 meters. Increase in gravitational potential energy, easy. The GPE formula is mgh. Mass 20, G you take 9.8, height is 4. After calculating, it comes 784, which will round to two significant figures as option D, my dear students. Okay. Next question, we proceed to question number 10. An electrician uses a lifting machine as shown. The lifting machine takes 4.5 seconds, the time to lift the electrician a vertical height. This vertical height is h. Okay. The mass of the electrician is 72 kilogram, which is m. The energy for lifting the machine is 2 kilowatt. Its rate of energy is called power. So power is 2000 watt. Kilo means 1000. So that's why we multiply by 1000. It is this. What is the efficiency? For efficiency, you need the useful output and total input. Okay, so time you have. First of all, input energy, power. Input power is 2000 given. Now we go for output. The output power, first we'll find the energy. Energy, when it goes up, it gains GPE. So GPE is mgh, which is mass is 72, G is 9.8, and height they told you 3.2. So this useful output energy 72 times 9.8 times 3.2, it is 2258 joules. Now using this, power output will be energy divided by time. So I will use this here. The useful output power energy is 2258. Over the time they gave you 4.5. 2258 divided by 4.5, 502 watt is the output power. So dear students, now you need the efficiency. Efficiency will be useful output power divided by total input power times 100. Useful output power is 502. Input was 2000. You multiply by 100. The answer is 25 point, they don't need efficiency in percent, so answer is 0.251. 0.25, option B. Yeah, this star question, you have to notice that such questions are called higher order of thinking, so you need to revise these questions later. I want you to rewatch this question again. We proceed to question number 11. Some altimeters use the change in air pressure to measure height. Altimeter means to measure altitudes, height. If the pressure is 100 kilopascal at sea level on a particular day, what will be the pressure at the top this meter hill? So this is the height. The density they are take this rho. You know, my dear students, density is rho gh. The pressure is rho gh. Rho gh. Due to this height, the new pressure, when you find 1.3, 9.8, 830. First of all, calculate this one. 830. This one is 10574 pascals, which is 1 point approximately divide by 1000. So it will be 10.6 kilopascals. Now this is the additional pressure due to this height. Okay, so now the question is, this is at a high altitude. Now they say take the densities. This initial pressure was how much? 100 kilo. Okay, so you have 100 kilo, and you know, as you keep going at high altitude, the atmospheric pressure decreases. So if the pressure decreases, so the net pressure you will do 100 minus 10.6, 89.4 kilopascals, which is approximately 89. Option is C, my dear students. It's a good question. You know, as you keep going on a particular altitudes, the pressure keeps decreasing. How much pressure will decrease? You will do rho gh. You will subtract this from the initial pressure. Because pressure has been decreased by 11 kilopascal, so the answer is 89. Like it's almost 11. Question number 12. Water can exist in three states: solid, liquid, and gas. In which states the motion of water particles only vibration? Only vibration means it is solid, which is ice. Which is ice, my dear. So option is C. We proceed to the next question, number 13. Ice cube has a side of 2 meter long and the cube contains the gas. Sorry, a cube has length this and gas has this pressure. So this volume will be 2 times 2 times 2. So V1 is 8 meter cube and the P1 is 8,000. Now, my dear, second cube has sides this. What will be the new pressure? So V2, the new volume, 4, 4, 4. The new volume is 64 meter cube and P2 is unknown. Boyle's law. You apply Boyle's law. Boyle's law says P1 V1 is equals to P2 V2. So P1 was 8,000, V1 was 8, P2 we don't know, V2 is 64. So divide by 64, 8,000 times 8 divided by 64, 1,000. A. Easy question. So it is A, my dear students. Okay. Question number 14. Which row gives the correct name for each change of state? So you just need to name, very easy question. So gas to liquid. Gas to liquid is condensation. Liquid to solid is melting. No, it is solidification or freezing. Solid to liquid is melting. Option B, very easy question. We proceed to question number 15. In an experiment to measure specific heat capacity, C, block of aluminum is heated and temperature rise is measured. The internal energy changes. E is delta E. The mass is M. Temperature rise is delta T. What is specific heat capacity? You should know, students, E is equals to MCAT. E is equals to MCAT. Now rearrange, hold the C here. So both of them will go other side as denominator. So E over mat will be the temperature change. E divided by mat. The option is C. We proceed to the question number 16. Which statement about the transfer of thermal energy is correct? Which statement about transfer of thermal energy is correct? Okay, so let's read and shortlist. All metals conduct thermal energy equally well? No. Some conduct more and some conduct less, like some are better than others in conductions. They are good, but some are better than others. Convection can only occur in solids or liquids? No. Actually, it is gases and liquids. So also wrong. Convection occurs in liquids? Yes, because hot liquid is more dense? No. Hot liquid is less dense. So also wrong. D. The radiation that transfers the thermal energy is a type of electromagnetic? Yes. And I will tell you its name is infrared. Infrared is heat radiation. Option D. Question 17. What is number of wavefronts per second? Number of waves or wavefronts per second is called frequency. Is called frequency. Is there any option with frequency? Yes. B. Number of waves, number of oscillations, number of vibrations, number of crests, number of troughs, number of compressions, or number of rarefactions per unit time is called frequency of a wave. Proceed to question number 18. Earthquake under the ocean can produce a dangerous water wave called tsunami. The table gives typical data. Okay, so here you have depth, here you have velocity, here you have wavelength. Okay, so our student suggests 3 conclusions about the data. So the deeper the ocean, the faster the waves. Yes, wave speed is always proportional to depth. Shallow, less speed, deeper, more. One is right. Longer the wavelength, faster the wave, also correct. V is equals to F lambda. More wavelength, more speed. Faster the wave, higher the frequency. No. During the change in depth, the frequency remains constant. This process is the refraction. So 1 and 2 are correct. The right option is B, my dear students. Okay. Now, what do we do? We chose B. We need to move to question number 19. The diagram shows what happens to the wave fronts as they enter the harbor. They are spreading. And you know, spreading of waves is called diffraction. Spreading of waves is called diffraction. So this is spreading, and spreading of waves is called diffraction, my dear students. So option is A, very easy, lower order of thinking question. We proceed to question number 20, my dear students. A ray of light passes from air to glass, as you can see. When it goes air to glass, they say angle. Now, angle of incidence and refraction are to be from normal. So this is 50, so incidence will be this one. So it will be 90 minus 50, which is 40. Refraction is correct. So incidence is 40, refraction is correct, which is 25. The answer is A. So please make sure angle of incidence, refraction, or reflection have to be from normal. After that, we proceed to question number 21. An object is placed in front of a converging lens. The lens has focal length f. This is focal point. Okay, so you can label this as focal point. Okay. Lens produces real enlarged image. Real image means the object distance should be more than f. Enlarged means object distance should be between 2f and f. So the object could be between f and 2f, so answer is B. If you like real images all the way like that, but enlarged should be in between them. Okay? Next, my dear. Question number 22. Question 22. What is the speed of electromagnetic waves in vacuum? You know that it is 3 into 10 power 8 meters per second. A wrong. Now change into kilometer. Divide by 1000. When you divide by 1000, it will be 3 into 10 power 5 kilometers per second, or 300,000 kilometers per second. The option is C. Proceed to question number 23. The starter in an athletics race fires starting pistol. There is a wall which is 60 meters away. You can see 60 meters. Take the speed of sound as this. How long after firing the pistol hears the echo? Now, my dear students, echo. You should know the echo is reflection of sound. So it means sound have to go and come back. So in this case, the wave speed formula for echo we use V is equals to double the distance over time. So you rearrange to make the subject time will be double the distance over speed. So 2, double distance is 60, speed is 330. So 2 times 60 over 330, 0.3636. B. Interesting question? A good question, my dear students. Now we go to question number 24. There you go, we reach electricity block. The diagram shows the magnetic field around the conductor which is carrying the current. Where is the strength greatest? Two things. Strength is greatest near the conductor. Strength is greatest when lines are closest. So lines are closest certainly near the conductor, which is option A. Because as you keep going away, the lines get farther, magnetic field becomes weak and weak. We proceed to the question number 25. A positive ion in the vacuum moves at a steady speed in a straight line. The potential difference between the two parallel metal plates, P and Q, are such that they are opposite. So I can easily guess if positive charge goes there, so it means up should be negative, down should be positive. And electric field, you know, it is always away from positive and towards negative, straight lines, equally spaced, positive to negative. So this is how electric field will look like. So the question is, which one is the correct diagram which shows the electric field? I already drew for you. So it is upwards. Why did I say up? Because positive charge goes up. So up should be negative. So this is how we do it. We proceed to the question number 26. In a circuit, the voltmeter reads 2 volts. After, okay, this is voltage V, and this one is charge Q. And how much is the energy supplied E? Go to the definition of electrical voltage or PD. Definition is the voltage is amount of energy supplied per unit charge. So energy will be VQ. V is 2, charge is 5, 2 times 5, 10, 10 joules. Option C. Proceed to next question, which is question number 27. Which diagram shows characteristic curve for filament? I will label all for you. If any graph bends away from current, it is filament or heater. Okay. If straight line, this is ohmic conductor. Ohmic mean constant resistance at constant temperature. See, if a graph bends away from voltage, this is always a thermistor. Memorize it. D, constant current with voltage, it is not even possible. Okay, so right option is filament, they ask you, and it is A. Question number 28. The diagram shows the electrical circuit. Which statement is correct? In the previous variant, I told you the current which is next to the battery is the maximum, the total. And then it is distributed here and here. Current entering is current leaving. So A1 is equals to A2 plus A3. Current is distributed in parallel. So current reading on ammeter A is highest. Yes, it is the highest. We don't have to read the others because this is the maximum current. Okay, so please ignore the resistors in this case, no matter which resistance is more or less. 29. The diagram shows the arrangement of resistors in series and parallel. Which equation is used to calculate combined resistors of all three? So first you have to do the parallel. Parallel is their product over their sum. And then in the end add the series one. So that's the final answer. The answer which matches this description is B. It's product over sum. A is sum over product. So right answer is B. Proceed to question number 30. An electrical engineer has made a pair of components P and Q. Resistance of P decreases as temperature rises. So this is thermistor. Okay. Now resistance of Q increases with temperature rise. It could be heater, It could be metal filament, it could be a lamp or something like that. So one increases, other decreases with the temperature. So total resistance of P and Q in series remains constant. That's interesting. So total resistance is what? Constant. Okay. When the temperature changes, the two components are connected in series, okay, to the power source. So if the resistance is constant, it means the voltage here is also constant. Yani total voltage will be constant. But the one which increases will rise. One which decreases will fall. Let's see the options. If a temperature causes potential difference P to double, then the PD across Q will be same? No. If one is double, other should be half. Because total resistance constant means total voltage is constant. B. The potential difference across P and Q does not change. No. P will increase and Q will decrease. PD across P increases as temperature rises? No. As temperature rises, its resistance will decrease, the PD will decrease. Also wrong. Some of the PDs will not change. Yes, I already told you because total resistance doesn't change. A good question. Option D. Now we move to the question number 31. The diagram shows a wire XY moving upwards in the magnetic field. The current is induced. I always tell my students that whenever you see induced current, directly Fleming's right hand rule. Fleming's right hand rule you will apply. So the current carrying wire experiences a force of interaction with the magnetic field, which rho gives direction of induced current and direction of force experienced by the wire. Anyhow, the force is by Lenz's law. So force will be certainly opposite to motion. Lenz's law says induced current causes a force which opposes the motion. You can shortlist the force first if you want, opposite to the motion. So if the motion is up, the force will be down. Now I will apply Fleming's right hand rule to find the direction of induced current. I will use the thick lines, magnetic field, north to south. Okay, current, sorry, the motion up. So current here along this green line we will try to find. So now my dear students, pay attention here. You can see this is my right hand. It's mother, father, child, mother, father, child. Mother mean motion, father mean magnetic field, child mean current. So it's mother, father, child. So first of all, adjust the magnetic field, index finger, from north to south, yani towards your right side, like that. Your right. And the force, motion is mother, father, child. Motion is up, keep it up. Field right, so index finger is into the page. Right now away from me. So away from me mean current is X to Y. Right option is A. So Lenz's law we applied and Fleming's right hand rule we applied. If you have any question, you can ask me. We proceed to the next component. Okay. Question number 32. Again, electromagnetic induction. The diagram 1 shows the magnet being pushed into the coil that is connected to center zero sensitive voltmeter. So look, my dear students, when you push, yani you can say in a different way, when the magnet south pole enters, yes, the deflection is to the left side. Stationary, not moving, the reading must be 0 because no rate of change. Now it is leaving. Now it is leaving, my dear. So you know up the magnet was entering. So when it is entering, it was to the left side. Yes. So when it is leaving, it has to be changed, reversed. So to the right side. So right option is 0 here and the right center here. Option C. Okay, so when it is stationary, no EMF induced, 0. If entering is to the left side, then the leaving will be to the right side. Question number 33. What is the purpose of brushes and split ring commutators in the motor? To ensure the continuous rotation of coil, you can say in one dimension, because it reverses the current every half rotation. So to keep rotation in same direction, option B. This is just a learning objective. You need to memorize this. The split rings, they ensure the continuous rotation of coil in one direction. We proceed to question number 34, nuclear physics. The diagram shows the beta particles being directed between them, in which direction they are deflected. Okay, so magnetic field is down, the blue color. Okay, if beta particles are going there, beta are negative. So it means ideally there is a conventional current which is opposite to the beta. You can assume. Now, whenever you want the force due to current, you use Fleming's left hand rule. Now look here, my dear, I will show you how do we do. Fleming's left hand rule is force field current. Force field current. Thumb is the force, index finger is the magnetic field, and this is the current. Now magnetic field we start north to south. So I will do it like that, north to south. Now if beta is moving to my right, so it means current I will assume to my left. So if I assume current to my left, magnetic field is down, north to south, so thumb is pointing my eyes, so out of the page. Option B, out of the page. Proceed to question number 35. An alpha particle, beta particle have same kinetic energy. Why does the alpha particles have large ionizing effect than beta? Large ionizing effect is due to many factors. I will write the factors. Large ionizing for alpha, more mass, more charge, large size, less speed. These are the four factors which make the alpha to be more or most ionizing. So let's see which option suits. Alpha has large charge, yes, and the large velocity, no, it has small velocity. Large charge was right, but the velocity is wrong. Alpha has large charge, yes, smaller velocity, yes. B. C says small charge, no, small charge, no. So option is B. We proceed to the next question, my dear students, which is question number 36. A student is carrying out experiment to measure the radiation from radioactive source. He uses the radiation detector and records the total count in 5 minutes. He does this 3 times with the source present and 3 times with the source absent. Source absent means just background radiation. Okay, source present means background with the actual radiation. Here are the results. With source present, source absent. So when source is absent, these are actually background radiation. So what is the average corrected count rate? Corrected means you subtract 25, 25, 25. So do it. Subtract 25 from each. 68 minus 25, 43. 73 minus 25, So not 25, this is 28, and this is 22. 73 minus 28, 45. 69 minus 22, 47. Take their average. So 43, 45, 47 divided by 3, answer is 45. But we need, yeah, these are 5 minutes. These are also in 5 minutes. So 45 you got. Now the question is we need per minute. So this is for 5 minutes. You divide by 5, the answer is 9, option B. It's a good question. Please watch this again. So what did you do? You subtract the background, you take their average, and then you divide by 5. Let's go to the next question. Question number 37. The count rate measured near a radioactive source drops from this per minute to this per minute 12 hours. Write the data. So initial count 542. Final count 94. Background radiation, how much? It's written. Background count is 30. So subtract 30 from both. It means initial is 512. Subtract 30. Final is 64. So, my dear students, whenever you have initial and final, you make a decay sequence. You make a decay sequence. So, initial 512 divided by 2. Uh, 512 divided by 2 is 256. Again divide by 2, 128. Again divide by 2, 64. So you started from 512 until it became 64. How many half-lives? 1, 2, 3 half-lives. Number of half-lives are 3, and the total time they gave you is 12 minutes. So the half-life will be the total time divided by 3, which is 4. 4 hours is the half-life, option C. Proceed to question number 38. What happens, now we are doing space physics, what happens when a protostar becomes a stable star? So proto to stable, the inward gravitational force is balanced by outwards force due to thermal radiation. So inward gravitational force should be balanced by outward thermal radiation. So option is B. The inward force due to gravity balanced by outward due to high temperature, it forms a stable star. Question number 39. The table gives information about some of the planets in our solar system: Earth, Jupiter, Mercury, Uranus. Which statement about these planets is correct? So look at that. Earth, more mass, less mass, more mass. Density, less density, more. Okay, I will use the color more with blue color and decrease with red color. Okay, decrease, decrease, increase. Okay, uh, de decrease, decrease, increase. So now we can compare. So which statement about uh, planets is correct? As the mass compared to Earth increases, average density increases. Look, compare these two. So mass was blue, density is the red, so decreases, not increases. You can compare. So look here, the mass is more, but the density is less. Option A is wrong. As the mass compared to Earth increases, gravitational field strength increases. Let's check. Okay, so more mass, more G. More mass, more G. So yes, they are in the same proportion. Option B. Look, my dear, I will just erase and highlight for you. Mass more, mass more. G more, G more. So option is B. We proceed to last question. What is estimate age of universe? Age of universe have two equations. One equation is 1 over Hubble's constant. Other equation is, you know this Hubble's constant formula, V H naught D. So it is D over V. These are the two equations for age of universe. So you have the option C. Thank you. See you for the next variant, variant 3. Have a nice day. Bye bye.